This is a review for practice test, the first part of chapter 3. And so the first thing we're going to do is we are going to take the derivative in order to find any critical values. So I take the 2x minus 3 and I set it equal to 0. So 2x is equal to 3 and x is equal to 1.5 or 3/2, whichever way you want to leave it. The problem starts with from -2 to +2. So what I'm going to do is I'm going to plug in the endpoints and the critical x value. So we got -2 squared minus 3 times -2 minus 5, which turns out to be 5. I'm going to plug in f of 2, which is 2 squared minus 3 times 2 minus 5, which is -7. I'm also going to put in 1.5, which gives me 1.5 squared minus 3 times 1.5 minus 5, and that gives me -7.25. This is the absolute min, 5 is the absolute max, and that's how we do problem number 1. In problem number 2, in order to take the derivative, I need to do the quotient rule. The derivative of x is 1. I change this to x squared plus 1 to the 1/2, which turns out to be 1/2 x squared plus 1 to the -1/2 times 2x. The 2's cancel, and so really we have x over the square root of x squared plus 1. So we multiply these two together first. So I got the square root of x squared plus 1 minus, when I multiply these two together, I get x times x over the square root of x squared plus 1 over x squared plus 1 and I need to square the bottom. So what turns out here when I get the common denominator, I need to multiply this up here. So I get x squared plus 1 minus x squared over the square root of x squared plus 1 over regular old x squared plus 1. X squared minus x squared cancels out. And so when I divide by x squared plus 1, that's the same as multiplying by x squared plus 1, 1 over x squared plus 1. So I got 1 over x squared plus 1 to the 3/2 power. Having said all this, the top I can't set equal to 0 because 1 never equals 0. When I set the bottom equal to 0, when I take both sides to the 2/3 power, I'm still left with x squared equals 1. I'm sorry, x squared plus 1 equals 0, which means x squared equals -1, and I get imaginary stuff out of there. So there is no critical values in this whole problem that we just did. And so all I need to do is I need to plug in 0 and I need to plug in 2. So when I plug in 0, I get 0 over the square root of 0 squared plus 1, which is 0 over 1, which is 0. When I plug in 2, I get 2 over the square root of 2 squared plus 1, which is 2 over the square root of 5. And so this is my minimum, and I know this is my maximum because 2 over the square root of 5 is bigger. For problem number 3, I know that this is going to have critical points whenever the absolute value is equal to 0. It also has a critical value when the inside is equal to 0. So when the derivative of the inside is equal to 0. So when I plug in 2x minus 9 equals 0, I get x squared equals 9, x equals plus or minus 3, but in my interval, negative 3 is the only one that matters. And when I take the derivative of the inside, we get 2x is equal to 0 divided by 2, and x is equal to 0. So the only critical point that's in my interval is negative 3. So f of negative 3, actually I should start with my endpoint, f of negative 4 turns out to be negative 4 squared minus 9, and the absolute value of that is 7. When I plug in f of negative 1, I get the absolute value of negative 1 squared minus 9, which is equal to positive 8, because the absolute value of negative 8 is 8. And when I plug in negative 3, I get the absolute value of negative 3 squared minus 9, which is equal to 0, which is my minimum, and 8 is my maximum. In problem number 4, up here I have my maximum. Down here is where my minimum is supposed to be, but in reality there is nothing. So this one has a maximum only. Alright, for this problem, when I plug in 1, I get 0. When I plug in 3, I get 0. So we need to figure out how to work Rolle's theorem into this. So what I'm going to do is I'm going to have to take the derivative. So in doing so, we are going to have x minus 3 squared, and the derivative of that is 2 times x minus 3 times the derivative of the inside, which is 1, but I don't really have to write that. And g of x is equal to x minus 1, and the derivative of that is 1. So this turns out to be x minus 3 squared plus 2 times x minus 3 times x minus 1. Now normally I would go ahead and tell you to distribute and simplify this out, but since they both have an x minus 3 in common, I am going to factor out an x minus 3. When I factor out an x minus 3, in the first part, I still have an x minus 3, and in the second part, I have a 2 and an x minus 1. And so now I have basically what I need to in order to solve this problem. So we got x minus 3 plus 2x minus 2 3x minus 5. In this part of the problem we have x equals 3, and this part of the problem we have 3x minus 5 equals 0. So 3x is equal to 5, so x is equal to 5/3. In these problems, we need to be in between 1 and 3. The only one that is actually in between 1 and 3 is 5/3, so that is my only answer for problem number 5. Alright, once again, when I plug in negative 1, I'm going to get 0 for f of negative 1, and I got 0 for f of 3. So I am going to have to take the derivative using the quotient rule. So f of x is equal to x squared minus 2. So the derivative is 2x minus 2x minus 3. So 2x minus 2. The derivative of x plus 2 is 1. So I got x squared minus 2x. Round 1, we have to do the other part first. We got 2x minus 2 times x plus 2 minus x squared minus 2x minus 3 divided by x plus 2 squared. So I need to set the top equal to 0. So we got 2x squared plus 4x minus 2x minus 4 minus x squared plus 2x plus 3 equal to 0. X squared, 4 minus 2 plus 2 is 4x. Negative 4 plus 3 is negative 1 equals 0. Because this does not factor, I'm going to have to solve by using the quadratic formula, or I could use the calculator to solve it. So we got 4 squared minus 4 times 1 times negative 1 over 2 times 1. So I got negative 4 plus or minus the square root of 20 over 2. So we got negative 4 plus the square root of 20 over 2 and negative 4 minus the square root of 20 over 2. This one is 0.236 and this one is negative 4.23. And since we need the number in between negative 1 and 3, that's my only answer. I will be doing these problems 7 through 12 on the next video.